So I'm going to carry on where I left off and start with question 25. We have a falling ball with a velocity of 12.7 meters per second, passing a window of 4.81 meters above the ground. Now the question is ambiguous because the answer actually gives you the time from when it passes the window to the floor. And it's ambiguous in the sense that it actually looks like it's asking for the whole time. In reality, the question is much easier. So here's the information outlined, and because we're only interested in the second half of the journey, it's quite a straightforward calculation. We're going to use a quadratic form because we're going to use this equation in order to solve for t directly. So if we fill in the information that we do have, which is the displacement, which is the distance from the window to the floor, we have the initial velocity and the acceleration, we can see that what we're ending up with is a quadratic equation. We're going to bring that over here to give us its full quadratic form. Okay, so what I suggest you do is you just plug this into a quadratic solver and you find that the answer should be approximately, to the correct significant figures, 0.3 seconds. There is another solution, but it's a minus value, so you can discard it. Okay, so now we're going to try question 26. A ball is thrown vertically upwards with a speed of 18.5 from a window that is 12.5 meters above the ground. So let me sketch that out. Okay, so there are three stages, in fact, to this question, but it depends on what we need to look for. It rises, reaches its maximum point, drops to the same position, and then reaches the floor. Now the first part, A, asks when will it pass the same window moving down? So in that situation, we're going to consider this stage here. And I'm going to complete the table. So you can see our displacement is 0 because it's reaching the same point. Okay, so its total displacement from the original position is 0. The initial velocity is 18.5. Now the final velocity, this is important to take note, is the same magnitude because of course the same conditions apply, only in the negative. Here we have an acceleration which we've assigned as being positive because the direction this way, we are taking it as positive. And the reason we're taking it as positive is because we've written the initial velocity as positive. So that means this acceleration is positive and this one is negative. So if you have the same displacement up as you do down, the same acceleration but only in the negative, then your final velocity at this point will be the same as it was here. So these two will be the same. So your final velocity is 18.5, but it would be minus because now its direction is down. The acceleration we will assign as minus 9.81 and t is an unknown. So there are a number of ways to solve this, but this is probably the simplest. So I'll substitute the values in as follows. So you can see it's minus 18.5 equals 18.5 plus, oops, this is a mistake, so that should be minus 9.81. So t will equal minus 18.5 minus 18.5 over minus 9.81. So your value of t will be equal to 3.77 or 3.8 seconds. Right, part B, with what speed will it hit the ground? Now this is now considering the second half of the journey, or the third, because we had 3 stages, didn't we? So this is now the third part. So we have an initial velocity, which we worked out to be 18.5 things are much simpler now because everything's in the same direction. So we're just going to call everything positive now. Let's complete our table for this section. Okay, so you can see there we've got displacement, 12.7. Our initial velocity is now plus 18.5, because as I just mentioned, everything now is moving downwards, so we don't need pluses and minuses, and we have an acceleration of 9.81. So the simplest equation to use would be v squared equals u squared plus 2as, and it's very straightforward substitution of values. Okay, which will finally give you a value of 24.2 meters per second. Now part C seems a little bit more complicated, but it isn't. How far above the ground was the ball exactly after 2.6 seconds? So we don't know what we're dealing with now. We just know that it goes up and it comes down, and at some stage, at 2 seconds, it's somewhere along this journey. Now, in our first question, we found that it took 3.7 seconds to go up and down to here. So probably in 2 seconds, it's on its way down. But it's quite high up, isn't it? So if that's 3.7 seconds all the way up 3.7 seconds, then by second 2 it's probably about here somewhere. But we don't need to worry about that too much because the equations will kind of just find that position for us. So what we have to do is, again, complete SUVAT, but taking into consideration the direction, the fact that we have a plus and a minus, because we're going to be using values that are both in the upwards and the downwards directions. So our displacement is an unknown. Our initial velocity is 18.5. Positive, our final velocity, we don't know. Our acceleration is minus 9.81. And our t is 2. So we could just use s equals ut plus half at squared to find where s is. Okay, so by substituting all of those values in, we will get a value of 17.38 meters. Now that S is from the initial position. So we have 17 meters that way. But of course, it wants to know how far above the ground it is. So what you need to do now is add 17.38 plus 12.5 meters, which gives you a total of approximately 29.9 meters.